Alright, this is 9.3 reflections. It's a transformation um, that is like a mirror to reflect an image. Okay, so one thing about reflections is that we have to have a line of reflection. Reflections happen about a line. If you don't have a line, you don't have a reflection. Alright, so basically all reflections revolve around this line, and we have different lines we reflect across. So we're going to look at a couple examples. Okay, so first one, example A, we're going to reflect across the x-axis. Okay, so and if you, this will come in later, but the x-axis is actually the equation y equals 0. You'll see why this is important later. All right, so here's the x-axis, this is our line of reflection. So all it is, a reflection is that their points are the same distance from this line of reflection, but in the opposite direction. So let's start with point C. As we can see, C is 1 unit up from the line of reflection. So to be the same distance, the opposite direction, we'll go 1 unit down, and this will be our C prime. All right. Same for A. A is 2 units from the line of reflection, so we'll go 2 units the other way, A prime. And then B is 4 units, and as you can see, we have B 4 units away there. So we look at your picture, it looks like a mirror image to me, so that is a correct uh, reflection. All right, now we're going to reflect about the y-axis. All right, so now we have a y-axis, and our image will reflect across the y-axis, going left to right. So again, same distance across a line of reflection, which is our y-axis. By the way, this equation is x equals 0. So D prime is 2 units away from the line of reflection. A is 4 units. C is 2 units away. And B is 4 units. And there we have our reflection about the y-axis. It's equal distance. And there, be careful to have the points at the same spot. The common mistake is to switch the A and the D. All right. And as you can see, A is 4 units away from line of reflection. If you switch the A and the D prime, A prime would be 2 units away. So be careful not to switch those up. All right. Be sure that the points are equal distance from that line of reflection. All right. So sometimes we're asked to reflect over lines that are not the x or y axis. All right. So that's why I said we see here we have the x-axis y equals 0, which is a horizontal um, line. So anytime you have y equals, y is going to equal your horizontal line at whatever number that is. And when you have x equals a number, this is going to be x equals a vertical line. All right, so let's see how we deal with this. So y equals 1, so let's draw our line of reflection. So here's 1 on the y-axis, horizontal line through. All right, y equals 1. All right, so that's our line of reflection. All right, so then again, same process, equal distance, opposite direction. So C here, so C is 1 unit from there, so C prime. B is 1, 2, 3, 4, 5 units away. 1, 2, 3, 4. We're gonna have to draw another line here. That'll be our B prime. And then A is 4 units, 2, 3, 4, 4 units away. 1, 2, 3, and 4. That is our A prime. All right, and then we have that reflection like so. All right, so now we have x equals the negative 1, so it's going to be a vertical line through the negative 1 coordinate, which is here. Let's make it straighter. All right. Okay, so same thing, equal distance. D is 1 unit away, so we go 1 unit the other way for D prime. A is 4 units away. 1, 2, 3, 1, 2, 3, 4. excuse me. I'm sorry, A is 3 units away. 1, 2, 3. So A prime, uh, C prime, and then B prime. Alright, and we have a reflected rectangle. Okay, so now we're going to go on to the next example. Example 3. So here we have x equals -1 against x equals, a number is a vertical line at -1 right here. Alright, so same thing, even though the line of reflection goes through the shape, you can still do your reflection. Just remember, so equal distance, the opposite direction. So C is 1 unit to the right, we're going to go for C prime 1 unit to the left. Alright, A prime is 2 units from the line of reflection, 2 units to the right. There's your A prime. B is 2 units to the left, so B will be 2 units to the right. So B prime. And we'll go ahead and make a triangle, and that would be the reflection there. Okay, same thing for part B. Line of reflection, y equals 1. Alright, so A is 1 unit up, so we're going to go A prime 1 unit down. D is 1 unit up. D prime is 1 unit down. Okay, B is 2 units away, 2 units down from there, so we're going to go 2 units up for B prime. And same with C. And we have that reflection right there. Alright, so that's just a good eyeball way of doing this, but however, there are some rules. So here in this box would be a good example of putting into your note cards. Alright, so if AB is reflected in the x-axis, you have a rule of A opposite B. So all you're doing is you're changing whatever your B component is here, the opposite number. So if it's a positive number, you make it negative. If it's a negative number, you make it a positive. So that's what that negative really means. The negative means opposite. Okay. So when you reflect about the y-axis, what you're doing is you're just taking the x-coordinate, the A here, and you're just changing that opposite. So if your x-coordinate was a positive number, you make it negative. If it was negative, you make it positive. Alright, so now we have two other rules here that you're going to need, because these here are going to be diagonal lines. And we have the parent function diagonal line of y equals x. This is your parent function. From Algebra 1, if you remember. And this line, if you remember y equals mx plus b, well, there's really a 1 in front of x, which is 1 over 1x, and the y-intercept is 0. So we have this slope of 1 over 1, and this line looks like that. If I can make it straighter. Okay, that's y equals x. That's your parent function line. Okay, from left to right, it is rising. All right, so to reflect about this y equals x, you're going to use this rule, which is basically going to shift the a and b coordinates. In other words, you're going to shift the x and the y values. So one way to do this is you can get your pre-image coordinates, put them down, and then get your image coordinates and apply the rule. So a is at -1, -1, 2, 3. B is at 1, 2, 1, 2, 3, 4. So we get 2, -4. And C is at 3, 0. Alright, so if you follow the rule, all we have to do is switch the x and the y, or the a and the b. So we're going to do the a prime, all we're going to do is we're going to move -3 to the first spot, and then -1 to the back spot. Same thing with the other coordinates. -4 will be in the x spot, 2 will be in the y spot, C prime, 0 will be in the x spot, and 3 will be in the y spot. Then all you have to do is plot your image. Alright, so -3, 1, So 1, 2, 3, positive, oh, down one. There we go. There's A prime. Negative 4, positive 2. That would be your B prime. And then your C is 0, 1, 2, and 3. There is your C prime. Alright, and the shapes match up. So if it looks like a reflection, you're right. If there's something deformed about it, it's two things. You either did something wrong or it's not isometric. So be sure to make sure that you check your picture. And if there's something going on funny there, double check your coordinates. Alright, so now we have y equals negative x. So this looks just like the parent function, except it has a negative slope here. So y equals mx plus b, we have a negative 1 over 1, x plus 0. So 0 here, um, negative 1, 1, and we basically have a line going the other way. Alright, so that is your y equals negative x line. Okay, so if you remember those two lines, you will be good for your exam. Alright, so we're going to reflect about this. So two things to note here. D and C. If you notice, D and C is on the line of reflection. So you can't go zero distance the other direction. So D and C are going to be the same coordinates as D prime and C prime. Alright, so the only two coordinates we have to worry about is A and B. So we'll make our little table. Pre-image, our image. Alright, so we have A sitting at coordinates of 1, 2, 3, 4, negative 4, positive 2. And we have B sitting at negative 2, negative 2. Alright, so A prime, we're going to use this rule now. Negative B, negative A. So we're still going to switch them just like before, except we're going to take the opposite numbers. So here we're going to have 2, negative 4, but we have to also do opposite. So 2 will be in the x spot, but it'll be opposite. So from positive 2 to negative 2. And then negative 4 will be in the y spot, but opposite that number will be positive 4. Same thing for B. Now, since it's the same number, the switching them isn't going to matter because it's the same number, but we still have to take the opposite. So we're going to get positive 2, positive 2. Alright, so plot those two coordinates. Negative 2, positive 4, A prime, and then B is 2, 2, B prime. Connect the dots. Remember, it's dotted because that is the translated image. That is the image, the new figure. Alright, so there is our reflection. Alright, just a note, so let's just look at C here. If you look at C, just to do it. So C is 1, negative 1. So C prime, following that rule, we switch them. Negative 1 will go up front, but we take opposite, which will be 1. 1 will go in the back, and since it's 1, we have to take the positive 1 to make it negative, negative 1. And you notice when you apply the rule, you get the exact same coordinate. That's because they're on the line of reflection, so we should expect that because you move at zero distance. That's why you would get the same coordinate. So I just wanted to show that real quick there. Alright, so here's a common one. This one you just kind of have to eyeball and kind of picture the line of reflections and see what the shape would look like when you reflect it. So if you reflect triangle 1 across the x-axis, okay, so x, y, which triangle will it be? So if we reflect triangle 1 about the x-axis, we get triangle 4. If we reflect a triangle 1 across the y-axis, we get triangle 2. Now, if we reflect across y equals x, you gotta kind of draw it out. That's the y equals x line there. So if we reflect 1 across that, we would get triangle 3. We also have y equals negative x. And that looks like that. So you gotta kind of memorize what they look like. Alright, that's negative x. And if we reflect triangle 1 about negative x,